Hello, everyone. This is the last lightning talk today before the coffee break. Do we want to do a little bit of stretch before we start? So try not to hit the people in front of you or next to you, and you can do the stretch to the top. Yeah, as far as you can. And then feel the blood circulation again. Okay, and slowly come down. Thank you very much. I could do more, but we're really close to each other, so I think this is as far as we can do. Hello, everyone. My name is Allison, and I'll be talking about building a React app that controls the device with OAuth. We have electronic vehicles that can save you from having to use gasoline. An EV is a great alternative to the cars that run on traditional fuel because you can always charge your cars with renewable energy. And that's part of what my company, Octopus Energy, does. Now, we have a heat pump for your house heating system. For those who haven't seen how a heat pump looks, it's like this. It's quite a big device, 1.5 meters wide, 1.2 meters high, that needs to be located on the outside of your house. It can save you a lot of money when it comes to the energy bill. But don't worry, I won't be talking about how heat pump works. So let's say that you have this brand new heat pump for your home. Now you're ready to save the energy bill while contributing to the fight against the climate change. All good. But it won't be a great user experience if you have to go outside of your house to control this device every time, right? As our customers start installing heat pumps in their homes, we decided to provide a feature inside of our web application for them to control the heat pump from their mobile devices or laptop. So how can we do this? How can we build a React app that controls a physical device? Well, that's the topic today. We're going to do this using OAuth. At this moment, our customers are using heat pump from this specific manufacturer called Daikin. And Daikin provides an API endpoint that can communicate some of the heat pump's data, such as on-off state, or the current temperature of the room or water, or the feature to set the target room temperature. And we implemented a single web journey that allows customers to authenticate with their Daikin account. In order for us to use or manipulate the data, first we need to request permission to access it. And this is the first important step because once we have the permission, then we'll be able to provide our customers a nice user interface with the data or even the feature to control the temperature. So here it comes, OAuth. What is OAuth? We see this very often. OAuth stands for Open Authorization. It's the industry standard protocol for the authorization. I wish that some of you who've already worked on the OAuth before could maybe remember what it felt like the first time you read the different documentations that are essentially talking about the same thing, but in different ways and relate to the feeling how confusing it was. And for those who will be working with OAuth later, I wish that you can remind of this example later so that it's clearer for you. So I'm going to be giving you the documented definition first and then interpret it, what that means for this specific project. OAuth2 is an authorization framework that enables applications to obtain limited access to user accounts on an HTTP service. All you need to understand from this one mouthful sentence is that it enables us, Octopus Energy, to obtain limited access to users' Daikin accounts. It works by delegating user authentication to the service that hosts the user accounts and authorizing third-party applications to access the user accounts. And here it means that it's delegating user authentication to Daikin and authorizing Octopus Energy. And there are 3 OAuth roles that we need to know. First one, resource owner. The resource owner is the user who authorizes an application to access their account. And like it says, is the user. The second one, resource or authorization server, API. The resource server hosts the protected user accounts, and the authorization server verifies the identity of the user, then issues access tokens to the application. And this is Daikin. It's a lot easier for you to just think, oh, that's Daikin, that's user, rather than have to remember this whole paragraph. And the last one is client. The client is the third-party application that wants to access the user accounts. And this is Octopus Energy. And the diagram here represents a typical authorization flow that I took from Daikin API documentation. A lot of arrows and boxes overlapping. Let's look at each step. The first step is user authorization request. The application requests authorization to access service resources from the user, which means basically Octopus Energy requests authorization to access users' Daikin accounts. And if you look at here, this is how the authentication page URL is formed. So if you've ever experienced, you say, sign in with Google, sign in with GitHub, it brings you to some page. And then with the box full of text that we don't have time to read with the button allow or cancel, this is how that page URL is made. So if you look inside this redirect to Daikin auth page function, inside there's a Daikin auth URL. This is the authorization API endpoint, and this is provided by Daikin. Response type code, it means that the application is requesting an authorization code grant. And there's a client ID. This is application's client ID. This is how Daikin identifies that the user is coming from Octopus Energy to authenticate the app. There's redirect URI. This is where Daikin redirects user to after authenticate the app. This is also provided by Daikin, and this value must match one of the valid URL that's specified in the registration process. And there's scope. Scope represents the level of access the application is requesting. And the state is a randomly generated hash set by application in the registration process and is available to the application in the response. And the state here is used to mitigate CSRF attack. Cross-site request forgery is an attack where the attacker can cause the victim user to carry unintentional actions such as change the password or email address in their account or even transfer some funds. So we want to make sure that this doesn't happen. And here you can see I'm storing that state in the session cookie. This will be used later, and I'll show you how I did that in the later slides. The second step is user authorizes application. The user must log into Open API environment and authorize the request. And this basically means that the user needs to log in Daikin sign-in page with their Daikin login credentials. And the third step is authorization code grant. If the user authorized the request, the application receives an authorization grant or the authorization code. So here, the user needs to click I agree to authenticate Octopus Energy, and then will be redirected to Octopus Energy heat pump page with the auth code and state appended in the URL. And let me show you how that URL looks like in the next slide. Access token request. The application requests an access token from the authorization server by presenting authentication of its own identity, such as client secret or client ID, and the authorization grant. And this is how the URL looks like after the user authenticates the app and is redirected to Octopus Energy website. There, I take the state from it and then compare it to the state that's saved in the session cookie earlier. And again, this is to prevent the CSRF attack. Only when they match, I then take the auth code from the URL just as the code below shows, and then I send it to the server, for example, as a GraphQL mutation input. And then the server requests access token with this auth code. Basically, it goes, here's the auth code, give me the access token. The last step, access token grant. If the application identity is authenticated, which means that it is registered in an Open API environment, And the authorization grant is valid, which means that the auth code is not expired or hasn't been used yet. The authorization server issues a pair of access token to the application. And now the authorization is complete. Basically, the Daikin will check the auth code Octopus Energy sends. If it's valid, then issues an access token. Testing in production. I wanted to share some tools that were useful for me when it comes to carrying end-to-end tests in the production. So let's say that you finished writing the code and are ready to release this feature to production. But then you want to carry an end-to-end testing. Basically, you want to follow the entire user journey yourself before you release it. But then how do you do this in production? Because all the variables that I showed you earlier, such as redirect URI or client ID, will be changed to production version. And when this happens, you cannot test this in your local environment anymore. So the tools that come in handy in this situation was Requestly, which helps you redirect requests matching a URL pattern to a different destination URL. So for example, if it was pointing localhost 8000, you can actually make it point to your production API endpoints. And the mod header, it lets you modify request header. You can use different production accounts to do the testing and then erase the record from the server. So these tools were something that I used myself personally, and it was very helpful. This is enough to do the testing OAuth flow in production as long as you don't manipulate the data. And now the application is authorized to make requests to the API in behalf of the user. Now, the Octopus Energy customers can control their heat pump with this functionality that we provide and can control the heat pump device at home. So I hope it sounded simple enough because that was my goal. Thank you so much for listening.